Welcome to the post-class activity for probability, developed as part of the MT StatPal project at Middle Tennessee State University. If you did the in-class activity for probability, you flipped coins and dropped candies on plates. One goal of the activity was to distinguish between empirical probability, which is based on observed data, and theoretical probability, which is based on a model of the experiment. The law of large numbers tells us that as the number of repetitions of an experiment gets large, the empirical probability gets close to the theoretical probability. This animation shows the law of large numbers in action. A fair coin is being flipped repeatedly. The blue line represents the empirical probability. As the coin is flipped again and again, the proportion of heads observed changes, so the blue values change as well. The green line is at the theoretical probability of heads, which is 0.5. This value does not change with each flip because the theoretical probability is based on the model of a fair coin and not on the specific outcomes being observed. As we increase the number of flips, observe that the blue line eventually gets close to the green line. You will also have learned that the models for a coin flip and a candy drop are the same. That is, the same probability model can be used for many different random experiments. Finally, you learned the probability rules, that probabilities are numbers between 0 and 1, and the total probability in the model should be 1. The experiments that you ran in class had only two outcomes, heads or tails for the coin, and left or right side of the plate for the candy drop. This presentation will focus on an experiment with more than two outcomes, roulette. Other experiments with more than two outcomes include playing cards, dropping candy on a plate that is divided into many pieces, and more serious outcomes in medicine, business, and science. The casino game of roulette consists of a large wheel that is spun and a small ball that is dropped on the wheel. A person wins if the ball falls on the number they have chosen. There are 38 numbers altogether, 1 through 36, 0 and 00. Half the numbers 1 through 36 are red, while the other half are black. 0 and 00 are green. Assuming the wheel is fair, what is the probability of getting any one specific number? Since there are 38 numbers total, and they all are equally likely to occur, the probability of any one number is 1 out of 38. What is the probability of not getting a specific number, for example 15? There are 37 numbers that are not 15, and 38 total, so the probability of not getting a 15 is 37 out of 38. Notice that the probability of getting a 15 is 1 out of 38, since it is one specific number. So the probability of not getting a 15 is 1 minus the probability of getting a 15. The complement rule says that the probability of getting the opposite of an event is 1 minus the probability of the event. This rule is now added to the rules we already saw. Suppose you bet on 15 and continue to do so 100 times. What do you expect to observe? Consider the law of large numbers here. Suppose instead of betting on just one number, we bet on a group of them. What is the probability of getting a red number? There are 18 red numbers and 38 numbers total, so the probability of getting a red number is 18 out of 38. What is the probability of getting a black number? Should it be 1 minus the probability of getting a red number? Does the complement rule apply here? Okay, what if you bet on red 100 times? What do you expect to see? Another way to bet on a group of numbers is to place a square bet. By placing your chip on the square formed by 4 numbers, you bet on all 4 of them. In the following example, we will be betting on the square bet that contains the numbers 2, 3, 5, and 6. Here you are betting on 4 numbers at once, so the probability of winning is 4 out of 38. Suppose you bet on both the square bet and on the red numbers. What is the probability that you win at least one of your bets? That is, what is the probability that the number that comes up is either red or in this square or both? It seems reasonable to decide that the probability of winning at least one of your bets should be the sum of the probabilities of each bet. Is this right? No, it is not right. The numbers 3 and 5 are in the square bet and are red. So if we add the probabilities, we are adding these numbers in twice. It turns out that in order to get the correct probability, we add the 2 individual probabilities, then subtract out the overlap. For this example, the probability of the square bet winning was 4 out of 38. The probability of the red bet winning was 18 out of 38, and the probability of the overlap was 2 out of 38. So the probability of winning at least one of these bets is 20 out of 38. This gives the general addition rule. To get the probability of at least one event, you add the 2 probabilities and subtract out the overlap. Notice that if the events do not overlap, we can use a simpler formula here. In conclusion, here is a summary of the rules we've discussed. You may wish to print this page for your notes. The probability rules state that the probabilities are numbers between 0 and 1 and that the total probability is 1. The complement rule states that the probability of the opposite of an event is 1 minus the probability of the event. Finally, the addition rules tell us that to get the probability of at least one of 2 events happening, we add the individual probabilities and subtract out the overlap if there is any. The Modules for Teaching Statistics with Pedagogies Using Active Learning project team consists of Drs. Lisa Green, Nancy McCormick, Jeremy Strayer, and Ginger Holmes-Rowell in the Department of Mathematical Sciences, Dr. Scott McDaniel in the University College, and Natasha Gerstenschlager and Brandon Hansen in the Mathematics and Science Education PhD program at Middle Tennessee State University. The MT StatPal project team is grateful for the support of the National Science Foundation and the Instructional Technology Division of Middle Tennessee State University.